All right, everyone, we're going to go ahead and get started. Thanks, everyone, for being here for our seminar today. It is nice to see all of you here and not dealing with tsunami evacuation stuff. So if anybody is here locally, that was quite a fun morning. So happy everyone is here and everyone is safe. This is our research seminar. My name is Cinnamon Moffett. I'm in the Associate Director of the Marine Research Support Team. It's a new title. I struggle on it every time. But I will be your host for today. This is a hybrid event, so we have folks online and folks in the room. For folks online, thank you for being here as well. Our volunteer, Roseanne, is in the room. She will help you with any questions you might have, either technical questions or questions for our speaker. Just put them into the chat box and we'll get those read out to the audience here in the room. For folks that are here, if you have a question today, just raise your hand and I'll bring you a mic and we'll make sure that folks online can hear. But again, thank you so much for being here. And I saw everybody signing in, but just a reminder, if you didn't sign in as you came in, either as a student or as a participant, please make sure your name is on that sheet so I can buy you cookies and coffee and not get in trouble. So I appreciate that. A couple of quick announcements. We have one more seminar this year, and that is it for 2024. So December 12th, our next seminar is Paul Erlemeyer, who is going to be talking about coastal Oregon conservation issues and strategies. So come back for that one, same place, same time, December 12th. But I want to kick it off as quickly as I can for today's speaker, who is somebody most of us know and love. So Drummond Wengrove is here for today's seminar. Yay! Drummond is the Innovation Lab Manager or iLab Manager at Oregon State University's Hatfield Marine Science Center. This lab is a prototyping, design, and development lab focusing on providing hands-on training and experiences through innovative projects, which I think he's going to talk a lot about today. Drummond has his bachelor's and his PhD in mechanical engineering from the University of New Hampshire. After completing his degrees, he did a postdoctoral research with, I'm going to say it wrong, Sandia National Laboratories, conducting experiments and research with the Combustion Research Facility, where he aided in the development of advancing a combustion strategy called ducted fuel injection to cut harmful diesel emissions. Pretty cool stuff. And then we stole him away and brought him here to Hatfield in the fall of 2021, where he is setting the culture of collaborative innovation here at Hatfield. The door to this lab is always open, and no matter your skill set, question, or challenges, he and his team has always been willing to play, build, and design with you. And so we are so excited that he is here. I was actually part of the team that envisioned the iLab when we were building this building, and Drummond has exceeded all of the expectations that we could possibly dream of for that space. So I am so excited to have Drummond here and to share with us. So I'm going to hand it off to Drummond.
Okay, thank you, Cinnamon. Can everybody hear me? Yeah, I mean, that's pretty much the seminar, so I think I'm done. Like, that's it. That's wonderful. Well, first, thank you everybody for coming to join me this afternoon. We have a couple different goals to kind of work our way through, but hopefully we can kind of expand on what Cinnamon just talked about, from what is the culture of innovation and collaboration and how are we supporting that, and what are some other ways we could think about doing that. So hopefully this will kind of inspire some thoughts that you might have there. So Cinnamon said, my name is Drummond Wengrove. What we want to talk about today is the iLab. But before we jump into that, I guess I have a project going on in the lab, and I should probably just multitask here and try and get that done while we're doing a seminar. So, I'm just going to kind of quickly get something running over here as well, just so that, it looks like I'm still working while we're getting everything done. So let me just quickly hop on here and come and share this other screen and work you through something. Okay, see if I've gotten my tech training done right. Oh. Okay, everybody with me? Okay, this is the book of knowledge, as we like to call it, McMaster Carr. This is where everything exists. So let's see, we got a project going on, and we got, let's see, there's some tube fitting I think we're missing. And yeah, I think it's a barbed hose to an MBT. So let's see if we can find it. I think it's going to be like a 3/8 hose. Yeah, it's gonna be like a metal fitting here. What kind of pipes? Yeah, I think it's like a 1/2 inch MPT pipe. Oh, nice. It's only 325. Oh, but I gotta ship it to the coast. Huh. Well, actually, wow. Happen to be a 3D printer here. Huh. Well, maybe I'll just try using that. So I'm just gonna actually download it. So these online hardware catalogs actually have the ability to download a solid model file right from it. I haven't practiced that today, don't worry. And so then I'm going to pull that into our solid modeling program. So where we do all our design and development work. And I'll open that up. Let's see if it's the right thing that we actually wanted. And okay, oh, nice. Okay, so now we have a nice virtual version of that. Looks right. It's going to be that barbed hose fitting into an MPT. Okay, great. So now let's run this and actually print this. So I'm going to just export it. Really, we're just doing a simple file conversion here. I'm going to come and put it somewhere I can find it, which is somewhere. Here we go. There we are. Thank you. Nothing like watching somebody else drive, huh? No backseat drivers in the crowd, please. Okay, so then I'm going to come in, and now this is what I'd really call the compiler. So we've converted it into a type the 3D printer understands, but it still has to have compiled code that it can actually run and create some item. So let's go through compiling this. And let's see, I want it to run pretty quickly. So let me move this. Oh, you all don't see that, so it doesn't matter. Okay, so we're going to set a reasonable density there. Temperatures look right for the type of material we have. Support looks okay. Oh, let me move that. I'm going to slice this. So this is compiling. Now it's going to be generating all the code that it needs to actually build this part. And so let's just take a look at it and let's drag it to some layer. I'll kind of rotate us up here. What is it going to actually be doing? Okay, that looks right. So it's going to be laying out that material. Okay, cool. That looks good. I'm going to just send this. You know, I'm just trying to get some extra work done here. Okay. Okay, I'm going to just send that to the printer. We'll see if that gets done in time. It's about 40 minutes. Okay, sorry, just had a quick thing I had to take care of. Okay, let's come back out of that. And then let's come back over here. And now we're off to the races. Okay, hopefully that starts making noises. I got to reshare? Okay. Well, we almost got there. I will come here and share this screen. How's that? Is that good? Okay, thank you. Team effort. Okay, so back in what we're actually going to be talking about today. So here's kind of the outline that I'm thinking about for today. So first, I want to get everybody on the same page in terms of the intro into the iLab. So who are we? What do we do? And where can you take your broken thing? So let's cover those as our first basis. And hopefully by the end of the seminar, you can at least leave with that. So then from there, I want to jump into some case studies. I want to use some of the projects that we've gone through and talked about and kind of developed over the last 3 years and use those as motivators as the style of projects we've taken in and the way that it doesn't have to be some perfect project before you come down and start to engage with us. So just kind of motivating that what can be fixed, the what ifs, and just expanding maybe how you think about prototyping. And then we'll jump into engagement and really think about some of the training we can do and perhaps some upcoming training that we're going to be thinking about. Now, it was kind of interesting starting a space called the Innovation Lab because it's kind of in the name what we're supposed to be doing. And I struggle with that a little bit in terms of like, what is innovation? And it's actually nice in putting this talk together. What I realized is that this is innovation. So having the right people, having the right ideas, having the right training, and having all the right kind of tools in one space that we can all share. That's how we're going to be innovating in marine science. And that's what I'll try and motivate kind of throughout that talk is how we've been going about that and how we can keep doing that with a wider group of projects. So this is what this space looked like. And I'm just going to make sure my workload is going here. Oh, it's heating up. Okay, we're doing good. I would zoom in on a camera there to show you, but what it's doing right now is just heating everything up so they can get the whole program running. So starting in an iLab, this is kind of the space, or the image it initially started with. And there was this really nice paragraph of what it wanted to be, of this 2,500 square foot space filled with CNC equipment and lathes and mills and design stuff and printers and lasers and all the things we need to do all the stuff. And after 3 years, well, it's kind of become that, and I'm pretty proud of that. So I tried to mimic that image and show, we've really done what we could over the last 3 years to fulfill that mission. So really trying to bring in the equipment, the training, the people, and bringing that all in a way that we're building a space for shared creativity, for shared collaboration, and really trying to support the work that is already natively kind of part of this campus. So just adding into what already happens here. So who are the people that do that? And so the iLab staff is made up of 2 staff engineers, myself and Jacob. And then we have a highly dedicated volunteer in our electrical technician / wizard, Bob Davidson. And then there is a core support that is, there would not be the iLab without it, of all of the student interns that come and work with us throughout the year. And we'll touch more on the kind of projects and the scales of things that they get into later on. And so I like to describe kind of what goes on in the iLab as a 3-legged stool. And so we talk about training, mentoring, internships, class support, and everything in that kind of undergraduate realm as one of these legs. We then operate as a prototype design and build shop. You can just pass us your idea, and hopefully we'll just pass you the thing back. And there doesn't have to be any connection or engagement there. Or there can be the complete opposite version of that as a project workspace, where you can come in with an idea, you can get trained on a system, and you can just be utilizing the tools to make it yourself. Now, most projects, we actually look to blend all of these together, and I think that's where we've seen the most success. But we look to make sure that we're supporting work in each one of these areas as we think about bringing in new equipment or bringing up to line new areas or anything that we're trying to do in the space, really supporting these different categories. Okay, that's good. Nice. See, being able to get work done multiple times. I was always jealous of all my friends that did simulation and modeling effort, because they just start something and then go off. So this is our version of that. So prototype shop. Let's start there. Let's work through some case studies, and let's kind of use this to motivate the kind of styles of projects that we work on. So I have an idea. I love it when people come into the lab and they start off with that. That gets us out of Outlook, onto the table, and over to the drawing board to be able to start and work on brainstorming an idea with someone. And project innovation ideas comes in an infinite amount of shapes and sizes. There is not a right starting place. There is not even always a right ending place. So I think the thing that I want to motivate here is almost all of project innovation starts as a mess and starts as just sketching ideas and kind of forming the solution space for what we might develop and what we might create. And then we enter into this loop. We think about brainstorming, designing, prototyping, and field testing. And sometimes the loop goes the other way. Or sometimes we start at prototype and we go right back to brainstorming. And sometimes we get to design and we actually just go right back over to brainstorming. And sometimes we go around this loop multiple times. But what I really want to emphasize kind of throughout this talk, and if you take nothing else away, it's we can start anywhere on any of these design processes, and you don't have to have this perfect idea. We love napkin sketches. We love what ifs over a cup of coffee. We love those pieces, and there's no right place to start for any tech development. So really, there's anywhere along here I think we can make progress on. And what we find is that there's kind of some buckets for categories. So I wanted to kind of use these different areas to explore some projects a little bit. We see a lot of projects that are efficiency-based. So I have 1 to 10, and they've worked well, so well, in fact, that now I have to do 100 to 1,000. Well, I don't want to just hire 100 interns. So how do we do that? How do we increase the efficiency of the resources that we have? So we see a lot of projects in those categories. We see a lot in the new case category, or new environments. You're taking something that is time tested and you're going to put it in a totally new space. So how do we kind of port that technology over? And then the very classic in marine science and oceanography is doesn't exist anymore. or for that cost, or for this use case. And so there's also that need to kind of re-engineer a lot of systems that have been developed before, but need to be refreshed a little bit. So we'll kind of explore each one of these a little bit. Now, I think I'm very lucky to be working in the Innovation Lab, but I think I'm even more lucky to work in an Innovation Lab for this campus, because I get to be the kind of front face of a lot of these projects, and I get to be talking about them a lot, but there's only an interesting outcome if it's an interesting project. And we are brought infinite amounts of interesting projects. And really that happened from day zero. I think this was like maybe 2 weeks after being here, I got somebody that brings in me a paper and says, this. We have this first box. So I'm brought in this paper and this box of electronics up on your right-hand side and saying, we've done it, it works, but can it be better? Can we make this more robust? We're trying to kind of understand what this can really do. And so from this initial design, we started with these questions of, can we make this kind of open source instrument that somebody else got working reliable? Can we make this a part of our dedicated field campaign? And can we design it in a way that it's easily built, that it's easily shared, that other groups can start to adopt these technologies? Yeah, of course, absolutely. Let's do it. And so this was a really good first use case where we were able to kind of work through the tool sets we have, refine some of the things that we were developing in iLab for the types of projects that we'll kind of see coming from this community. And we use the machine shop to develop a lot of the components. For this system, it is a drone-mounted single-point ranging device for being able to measure the height of a drone for photogrammetry. So it does not, hopefully, go in the water. So it could be 3D printed. And so we could make it a very light and very cheap housing, therefore bringing that whole cost down. And we also designed it around hand solderable printed circuit boards. So the PCB, or the kind of board that holds all the electronics together in there, we designed it in a way that really anybody could put it together with a soldering iron. You didn't have to have a specific machine or a reflow oven or some of these more modern pieces of technology, but not necessary if you don't have the packaging constraints. So we built it in this way that we could kind of have a wider group of labs assemble the system. And we got to this, as we see here. As one other point that I want to drive here and kind of carries through a lot of the projects is, once designed, costs about $800, about $500 in parts, but that once designed piece is really key. Design effort always takes perhaps more than people might think. Design effort is always a really big chunk of time when we're developing any project. But when we do these in-house designs, we then retain all of those designs, and we share them certainly as well. But then it's something that we can mature over years, we can build again and again, and that support of that design effort really is able to then drive down the final cost of a lot of these systems and allows us to keep maturing that design over time. So a lot of these systems, have a larger design cost, but then once we're able to go through that, we're then able to make them pretty effectively and pretty cheaply. So then, of course, we had to make a whole fleet of them for drones here. And then, of course, we're very proud to have been a part of the paper that came out of this system, written by our third floor GEM lab and by Casey Bierlich. And then, of course, what happens when you write a paper and then you publish it and you put it out to the community? Well, everybody wants one. That's great. We're super happy to be a part of that. We've sold close to 50, maybe a little over 50 at this point, and have actually gotten to the place where we're starting to work with a small business to take over some of the manufacturing of these systems and kind of take it into the next revision. We've been making this for long enough that most of the electronics have actually changed and needs a little bit of a redesign, which is awesome. It's wonderful to see something exist for so long that we have to keep growing it. So we're really proud of this, and this was our first project right out of the gate. I'm like, oh my goodness, this is going to be great. Okay, so then switching to a different scale, this was another project that came really right out of the gate. And this was I have this. I bought it once somewhere. I don't really know where that is anymore. And I'm not sure they even really make them, but it still kind of works. If I hold it here and then I don't really touch it, it'll run and it'll do what we need. Well, okay, that's great. But how can we again think about kind of reverse engineering a system, improving the efficiency so that you don't have to sit there and hold it for the whole trial, and making that in-house design so we can grow this design over time and increase your lab efficiency time. So we developed our first round prototype. Now the good and the bad of living with these designs is after we designed it and made it for upstairs, well, after a couple of years it broke. So the beauty there is that we then get to redesign that system. And we had this year a second revision developed by an intern here. And quite honestly, they did a great job redesigning it. It is more cost effective. I had to ask if it's still working, but I think it's still, yeah, it's still working. Okay, great. It's still working. And, I think that developing that mature design is one of the things that we're really happy to see over working with groups over years. So that was great. Okay, then we get into these spaces where we're kind of given a parameter space. So we're thinking efficiency again, and we're thinking otolith prep for microscopy. Well, again, that in that 10 sample range, okay, that's pretty straightforward. I don't have a sense of net time taken, but it's something that a trained individual can work their way through. But imagine you're going to hundreds or thousands now. Well, that's going to be a large amount of time. Now, the good and the bad of being an engineer is I see a problem written out in this way, and what I imagine is this big, beautiful black box where samples just go in one side. It's automatically processed and all the things and analyzed and everything, and just comes out with data on the other side. Well, that didn't really suit the needs of the researchers here. They really just needed something to increase the efficiency of a process. Luckily, there's multiple minds that all work on those projects that we work through. And another engineer came up with a very simple, very clever, very clean way of being able to run these systems. So I don't have a name for this. Maybe Polisher 2000 should be the name of this one. But so what was ended up developed was a series of polishing wheels where you can just simply change the medium or the sanding medium on each one of them with just simply Velcro, have little adjustable speed controllers. And we made a few of these systems, and then it's much easier. Instead of sanding something by hand on multiple different sheets of sandpaper, you can then go through them much more efficiently and hopefully much more predictable. So being able to stay consistent with these is a big part of it. If we can stay efficient and predictable, that plays a huge role. Again, I think there's a paper in the work on this piece, so we'll look forward to more orders soon. But this really mimics kind of that, what is the right piece of efficiency that we need to add in to any of these projects? How do we tackle the single bottleneck for any of the processes you have in the lab or in the field? So I love overcomplicating and then seeing how simple it can get. Okay, then it doesn't exist. Well, for that cost. So another long-term project that we've worked on for a while is the space of eDNA. And this is a project that we started in the winter of 2022. And it was the desire and idea to bring together a team. That team was consistent of a student intern and an outside business. And this outside business had the kind of idea of how they wanted to change this instrument and how they thought a new instrument could work, but they didn't necessarily have the capabilities to be able to refine that prototype and go through the testing there. So we partnered with a company called Hatfield Marine out of Alaska, came and joined forces with our prototype team down here, joined forces with an excellent intern team, and we're able to develop an instrument, test out here in the Bay, and actually produce a plot of data. Now, you'd have to ask Charles what that plot of data actually is. I just know it's really pretty colors, and it actually did something. It's like, there is life. But luckily, again, we have the expertise within this community here to be able to all fill in those niches. I don't have to be an eDNA expert. I just have to be able to help refine the small component that we hold. So it's a beauty of working in this community. So V1, so what were the kind of pieces that we were tackling? So this outside researcher and company really thought that there was a way to create a much more flexible design that used independent channels. So eDNA is really just an underwater pump. It's pumping water through a filter medium that's then going to be collecting any of that particulate. Hopefully there's then DNA on that filter. That filter is then, if it's staying under the water, getting preserved, and then being pulled back into the lab, and fancy lab science happens to create beautiful plots like we showed. So this design was really trying to target something that is really scalable, is not something that is $100,000 and will be perfect for that one use case, but something that would be working for a one-channel version or a four-channel version or deep water or shallow water or backpack driven. So how do we have something that is kind of a single system that can really be adjusted based on the use case you needed? So thinking independent channels, so there's not the need to try and preserve or clean between different channels. So you don't have some of the issues that some of the other samplers have of cross-contamination. And then really scalable in terms of it's just a question of how many do you want to use and adding those up. An easy to use interface. So I'm sure we've all engaged with ocean instrumentation where you have to remember how to use command line or how to Bluetooth to it or connect to it, or you need a DB9 to a USB or some, like there are infinite challenges there. And I think one of the really nice pieces in a lot of these projects is working with the talent here at OSU. There's on the order of what, 10,000 undergrad students here that all are creative in their own ways. And they developed an easy to use interface where it's Wi-Fi connection, you can program it from a closed bottle, and all of the connectivity happens through their own interface. So really nice, easy to use space that solves a lot of problems I've seen with other instruments and relatively low cost. Now, you know, we're still in a marine science space, low cost is still low with quotation marks on either side. And we're really proud of this because we were able to get this system together, run through a series of testing, and then Genevieve, the lead on this project, was able to go and present this at the Oceans Conference this fall. And so really trying to be able to blend those different legs of that stool together. So how do we blend that training with professional development, with all of those pieces, and really have a piece of technology in the end of the day? We're also lucky enough that this has been a longer range design. So in terms of the number of times we've gone around that circle is, I don't know, 10, 12, how many times have we gone around that circle? A lot. So we've really iterated this a number of times because we really started at ground zero with this whole project. So being able to get to the second revision of this project in the water, we're really proud of. So this past fall, we developed the second round here, really trying to tackle some of the main challenges that we faced with that first system. So reducing a lot of the sizes, really simplifying the overall manifold, giving it a more robust pump head, and then getting it in the water. And also looks a lot prettier. So that actually goes a long way too. And then this is currently undergoing some testing up in Alaska, and we're going to be searching out some efforts to keep this testing and innovation going with this system. So this really models, you know, some of the other versions that we're trying to do that span all of those different pieces and bring together professional training as well as kind of needs in our research community. Okay, again, we just get these papers that just get dropped off on our desk and they go, can we make one of these? Is this possible? This is another one of our favorites. It got dropped off and, you know, it was a cup of coffee in one hand, paper in the other hand. We love when people come in that way. And there's these series of pictures in this paper that talk about how you might be able to take a CATS tag, tag that gets used by the marine mammal group to be able to deploy onto a whale. But instead of trying to approach the whale and actually have to get close and be able to tag it with a pole, maybe trying to drop it off of a drone. And there's a number of benefits here, but what we get really excited about is, oh, we get to drop things from drones? Oh, that sounds awesome. It also, I think, has still the title of the most creative project that we've had title-wise in our lab space. And we have a project board that sits up at kind of the end of our lab space. And one of the titles on there for this project was Cats on Drones. And every tour that we would give, you could see when the person would see that title and just go, what in the world are you all doing in here? Like, did you go through the proper permitting to put a cat on a drone? Yeah, actually we did. You don't need any. The other point that I want to drive home here is the marine science community is a really wonderful one. Not only do we get this paper and we get these pictures, but in reaching out to this community and the authors of this paper, they get really excited by somebody else trying to work on this, and they are sharing all the designs. They, you know, there's so many times we would have had to go around that design circle where instead we get to start right off with what someone else has already done. They're telling us everything that worked and hasn't worked and all the different spaces to try. So we're not starting from zero on projects like this. And that really means a lot when there's really hard technical problems that we're all trying to solve for the community. So really it's a shout out to the community here in terms of how collaborative you already are. It makes our job really easy. And so we pretty rapidly, we were able to work with a student intern and be able to get one of the cats onto a drone. And then we went through a series of testing. So I wanted to kind of show what prototype testing looks like and what that process looked like for this project. So we're going to go through a series of tests. We're going to start off with just dropping some metal objects. We're going to go into a pool, and then we're going to get out into the estuary. So you don't want to drop the expensive tag at first. So we start off with just a block of aluminum. Okay, works. You can drop it. And then we start out with a pool. Everybody recognizes what this is. Okay, wow, we can drop something. Now we go to the whale paddleboard. This is being towed down the estuary, and now we've gotten the dropper mechanism to work, but how hard is it to fly a drone over a moving object and hit the button at the same time? And they're getting closer. Oh, we hit it. Nice. And they're refining that pilot driving skill. Oh, double backflip, and it lands. Until we've actually landed on it, and it was immensely fun to watch this field team come together, solve this technical problem, and share this video with us. Ah, never gets old. Yeah, that's this team here. So that's 5 minutes. That's collaboration. That's what we're trying to do. We're trying to take what is that small hurdle that would annoy you, that would frustrate you, that would make you not want to go after that project and solve that problem, because the rest of it you already have, and it's wonderful to join forces with. So that it really mirrors that well. Okay, so that's the prototype shop flavor of things. So that hopefully that gives you a width of kind of small scale, large scale, outside driven projects, inside driven projects, in water, above water, kind of a wider flavor in terms of what we work on there. And hopefully that motivates that you don't have to have a perfect start point for any of these prototype projects. Come in with any of those ideas. So let's jump into the project workspace aspect of things. So our project workspace. So there's a number of different areas that we see a lot of individuals using. And so we try to make sure that these areas are kind of rentable, are ready to be able to be used, are easy to come in and use. So from rapid prototyping to our machine shop and project workspace to the weld shop and to the electronics studio. These are all areas anybody can just come in and come use. The other thing that we've started to do more, especially in the summer times, is reservable laydown space. We've seen this become more and more popular. We're really happy to be able to support that. Where that whole area in front of our garage door, we will allow anybody to take that over for project staging, whether it's mobilizing for going on one of the boats, whether it's prepping some buoys you need to go out with. The only ask that we have is that you talk to all of our student interns about your project. So trying to bring more projects into that space so that we're just understanding more of the tech needs and the tech development that's happening here on campus. And it's dry, there's power, and there's Wi-Fi, so it's nice. There's lots of equipment that we'll rent out as well, from media capture equipment. We're building up some low-cost sensors that we'll be able to have so people could not only prototype a sensor, but how do you prototype a field question or a field campaign if you don't have the ability to go and buy some of these things. Working on revamping some open CTDs that we could just keep on the shelf and kind of try and tackle some of those low-hanging fruit questions with kind of quick instrumentation. And then lots of toolkits and things to be checked out. But perhaps, these are nice pictures, but they're not spaces you see yourself working in because they're not something you've been trained in. So we have Innovation Tuesdays. Yeah, starting next term, we are going to be starting a themed workshop throughout the term. And so the first Tuesday of every month, we're going to be tackling an item within a specific theme. And this is a long time coming, so I apologize to anybody that I promised that we'll teach a workshop to and we haven't yet. It's here. We're going to do it. So for the winter term, we're going to be tackling electronics. We're going to be working on these 3 different areas. We're going to be spending about an hour to an hour and a half working in the lab. but I do not have a time determined yet. So I wanted to pitch this and kind of promote this now. And then after this, I'm going to be sending out a survey in our listserv. Tell me what time works. Tell me when people would show up. Maybe we have multiple times, maybe we have it move around. I want to know what works for you all so that we can start to train more people and get more people comfortable in these areas in the lab. So we're going to be going through these different topics. Everybody is welcome. We're covering soldering, wire to wire, through hole soldering, what is a PCB, all those pieces. We're going to be covering multimeters. It's the like hidden window into the black box of electronics. It's a wonderful tool. And then we'll be covering power, so batteries, power supplies, and maybe even a little AC/DC. Okay, so please look for that survey and please give me your times it'll work. Okay, and we're going to be working through different themes on each term. So if you have thoughts in terms of what you would like to see in the next term, please feel free to put that in that survey as well. Okay, so that's that project workspace. Now let's dive in and kind of look a little bit on this training and mentoring. What have some of the internships looked like? Where are we going with some of these internships? And across all of these spaces, I'll keep reiterating the beauty of these projects come from the community that we're a part of. So one of the reasons I think that our intern program has been really successful is because they're embedded into a really creative, really inspiring community that is such a part of their own work. So the problems that we get for them to work on make it such a good internship. So that is, please keep giving us your problems to solve. We're really proud of the program that we've been able to build over the last 3 years. We've had roughly over 20 interns participate in the internship through the iLab for a little bit over 15,000 hours of in-lab time from undergraduate students. We've been able to recruit from both OSU as well as community college, and it's something that we'll look to continue to grow over the next coming years. So we're really proud of kind of the width of students that we've been able to attract into this program. Also really proud of the styles of and types of projects that they've been able to tackle. They've tackled projects for PMEL, they've tackled projects for NOAA, they've tackled small instrumentation projects in water, out of water, kind of all really wide range. And the reason that we get to work on so many projects in the lab, at the end of the day, there's 2 staff members there, but these interns are really a huge driving force of the width of projects that we can take on, that we can investigate. So I'm really proud of the work that they've been doing over the last 3 years. But I wanted to highlight kind of one of the projects that we ramped up over this last summer, and it's something that we're going to be looking to grow and mature over the next couple of years. So we do lots of training programs and we do lots of widgets in the end of the day. But what I always think about is how can we take that widget and actually have it solve a problem? How do we take every time we're doing prototype training and target some tech need, and not only have the outcome be the trained individual, but also have the outcome be the piece of technology that goes and answers some question. So we were able to partner with Mid-Coast Watershed Council, and a huge thank you to Cheryl Horton and to all of her team for helping support us and helping us develop this project over this last year to try and tackle this kind of question. How do we take some local community-based problem, spend a week, take 10 talented students and tackle it? So that's what we did. We targeted a project that the Mid-Coast Watershed Council is working on in Ekman Lake. They're having a number of challenges there and are trying to classify overall water quality and behavior there. And one of the pieces that they're trying to search after is temperature. So the need for a low cost, pretty easy to make, pretty easy to fix temperature sensor was the target problem there. So we spent the first day of that week actually going down to Ekman Lake with that team, doing some investigations, trying to understand how they're taking data and trying to understand what they need. We then got to brainstorm. We then got to coming up with what the sensor package would look like. And we spent three and a half days really tackling this project of what could it look like? What do we have in the lab? How do we make these things work? And then we got into prototyping them, testing them in the lab, and then actually deploying them out in the field. And in the span of a week, there were 10 temperature loggers that were designed, fabricated, developed. And the range of interns here were up really wide. For some, it was their first time soldering. For some, it was their first time machining. For some, they had never touched a solid modeling program. So being able to tackle these pretty low-hanging fruit, but still, complicated design problems, but single sensor, but a robust measurement that we're able to perform here. Now, in this first year, we had a couple leaks, we had a couple challenges with them, but that's native to any of these programs. But we're really excited to spend the next number of years kind of building up these styles of programs where we're kind of doing these prototype boot camps or workshops where we're able to tackle real problems and have real outputs, both from the training as well as from the tech side. So if you have other ideas in this place, please also bring them to me. Okay, so that covers really kind of the width that we're working on here in terms of the internships, in terms of our prototype shop, and in terms of the project workspace. And I think what I'd like to end with is just come stop by. That's really what we'd like to encourage. We really do our best to have an open door policy, and we really would like to encourage everybody that has not, that to make it part of your habit to come stop by. You are not interrupting, you are not being a pain. That is what we love that pulls us out of meetings and emails. And my second work is almost done, but with that, I'll end, and thank you for your time. Okay, now we have extra time to brainstorm and come up with some tech things. So what do you got?
Right. It's all up to you now to ask questions and see where we go. So we're going to bounce back and forth between any questions online and any questions in the room. Roseanne, anybody online yet? Okay, for folks online, if you have any questions for Drummond, please put them into the chat box. For folks here in the room, any questions, ideas, thoughts, problems you want solved instantly?
Ooh, yeah.
Come on. All right, hang on just a second. Let me figure out how to get to you.
Thanks, Drummond. That was awesome. This is kind of a personal question, but I was just wondering how you kind of went from your PhD in combustion something or other and then decided to go down the coastal engineering side of things.
Yeah, that's a great question. And I almost put a slide in here kind of talking to that, but I wanted this to focus on the we instead of the me. So, but I'm more than willing to talk through those questions. I think really, so my PhD was actually in fluid mechanics, and interesting enough, fluid mechanics actually drives the behavior of combustion, and it drives the behavior of all of our marine science space. So to me, actually, it's been the exact same field, interesting enough. It's just one's hotter, one's colder. I will also say that, I made a slight joke in our last seminar of the fact that I got corrupted in the end of my graduate school by teaching in an ocean engineering space, and the previous seminar presenter was somebody that I taught with. So I think I kind of had this flavor at the end of graduate school around ocean engineering, marine science, and the kind of unsolved problems that existed in that space and the harshness of that environment. So the combustion side was fun because it's, it's blowing stuff up. That's pretty harsh. That's fun. But coming into the marine science side, there's a lot of unsolved problems, and they're great, really good engineering problems. That brought me back into this space. I think the other thing that I'll kind of touch on is going and working in a national lab. I think the main thing I realized is I really love being research support. I don't necessarily love being the PI of a project. So I think that's really an interesting piece where you can go through graduate school, you can go through getting a PhD, and there's still lots of places that are really great to go and work in. So that research support, I think that's really my calling. That's what I really love. And I was lucky enough to be able to blend that into a previous love of marine and fluid dynamics. Is that okay? Good question. Yeah.
All right, questions online. Go ahead, Roseanne.
How do you prioritize the projects your lab will take on? How do you manage timelines and expectations for project completion when students have to work around classes?
We have a magic 8-ball in the lab, and that's actually no. Quite honestly, that's a great question, and I think project management is a skill that I will continue to learn and continue to work on and refine, as really anybody in these spaces do. In the end of the day, there's a big kind of dividing line between when we take on an intern project and when we take on a prototype job shop project. In one thing that we've really learned is that for an intern project or for one of those, the main deliverable has to be learning. You can't focus on a key dedicated timeline. It has to be the learning of the student. That has to come first. Now, if you've timed things well and you've given the space to be able to grow, I think that you can easily couple that into project deliverables and those kinds of spaces and due dates associated with that. But you have to be focused on the learning, and that has to be the main outcome of those projects. Now, sometimes things bounce back and forth, and I think the other answer to that question is that it's a dance. It's a dance between all of those pieces, between what the customer needs, what level of finals the student is taking, what other projects we have going on, and it is always a dance between all of those pieces where we're just working to communicate across all those places. So hopefully that, I don't know, it's dance.
All right, questions in the room? Other questions?
You're gonna run for it.
Oh, come on, Lee. Meet me halfway.
All right. Thanks. Thanks, Drummond. This is less of a question, more of a comment, but yeah, I just want to first say that Drummond and his team are awesome just to work with, and all his interns and everybody in there. So I highly encourage it. But one aspect you didn't talk about is the money. And so I know if there are PIs in the room, I'll just make a comment that it's also quite seamless. So when he highlighted a few of our projects that we've done with the iLab, and basically we go to him with this, idea, and he says, okay, blah, blah, blah. And then eventually we get to the point where we have a sketch of an idea of how much parts and labor, and he sends it to me and I say, yep, that looks good. Or I can give feedback like, oh, that's stretching my budget, I can't make it. And then we downscale the project. And then eventually I give the green light and we go through with it. And then paying is just with an index. So I just mentioned that because I know PIs in the room are always thinking about the money and how to make it go. And that's, anyway, Drummond, and the fact that it's in-house just makes it super easy to work. He understands budget. He knows what that's all about as well. So he's definitely able to scale to your needs and make it easy.
So tagging on that, Drummond, how do you work with our agency partners?
That's a good question. And first, thank you, Lee. I really appreciate that. We also take credit cards too. So I think luckily, the iLab as the we is stepping into a space where a lot of these problems have already been solved. So working with agency partners is pretty straightforward, from our cooperative institutes and from the ability for us to take credit card payments. So a lot of those have been solved. It always requires a conversation based on the total amount, based on the timeline, based on are you academic financial year, are you federal financial year, when does this all work? But those are all pieces that can be sorted out, and we, as well as the financial team we work for, is pretty committed to not having that be a barrier. So I haven't had that as a stop to any project thus far.
Thank you. Roseanne, question online?
Yeah, how many will the workshops accommodate? And have you had any interaction with the wave energy project?
Oh, yeah. So the first part of that was how many projects do we accommodate?
How many people
Oh.
will the workshops accommodate?
I don't know.
The workshops, Tuesdays.
Workshops. The workshops. Thank you. That's a good question. As many as I know. I think that it works really well to have on the order of 10 to 15 people in that space working on projects. I would love it if we get 70 people signed up, and we will come up with a way to make it work. We will come up with multiple sessions if we get that amount. I will by no means cap that at this point. I think our goal there is to grow interest, and you can't cap it if that's the case. So there's no cap thus far. And then the Wave Energy Project, again, I think that we felt really lucky to be able to start the iLab in this time at the end of COVID. Everybody had been sitting at home drawing napkin sketches of all these project ideas and just kind of was able to bring them in as soon as we started. And then there's all of this energy broadly at OSU between wave energy, between growth on this campus, all of these spaces. So we haven't directly worked with any of the wave energy, but we have a lot of conversations with the team there. in terms of being able to provide local support for their project developers. So as those groups come out here to test something, they natively won't have everything they need or will break something. And we don't want to be making them fly back to their own workshops or be sending parts. So we've certainly had the conversations of when they do start testing, being able to set aside time, just as we set aside time for before somebody goes out on a cruise, to make sure we have a lot of FTE to be able to help on those projects.
Questions in the room? All right, 1 second.
Yeah, you have that big crane on the ceiling in there, right? What have you done anything cool with that yet?
Yeah, that's how we clean our windows. No, I wish. Have we done anything cool? You know, I think when I started and before I was able to hire on other individuals to come and work in the lab, I had to play a lot of equipment feng shui. So moving around 10,000-pound equipment on my own was tricky without that. So I consider that to be very cool. Some other interesting things, I think we're having some issues, or a local team here, Sarah Henkel and her team, were having some issues with a box core. And so we've actually used it to kind of mimic test deployment systems as well, where we had a wheelbarrow of sand and we're kind of trying to understand why it wasn't closing right. So I thought that was an interesting one. Oh, we also did there was a high school research project last year through the H2O program where they were looking at the tensile breaking strength of printed plastics submerged in different salinity water. And they were looking like, does plastic degrade over time? And we hung it off of that and then hung a suitcase like weighing mechanism off of that to see how it would break. So we can kind of use it as a tension point. We've used it as a test deployment point. We've used it to move projects around the space. It gets used a lot when we think about mobilizing with that area, when a team will assemble something there, use it as a top pick point, pick it up, back their truck in, drop the thing down. So like that's a really nice use point, saving a lot of backs. So a couple different ways. It also looks good.
You're talking about printed plastic. I think your second project might be done up there.
What's that?
I think your second project might be done up there.
No, this is my extra work. I was just
Extra work.
Yeah.
I think we got another question online. Go ahead, Ms. Ann.
Are there anticipations of expanding the lab itself more than it already has based on a growing workload? Is there still space within the lab for more equipment and stations? And this includes staffing as well.
Oh, does that person have some time to help us write some grants? Because yes, absolutely. So what is the current workload? How do we think about expanding, and what does that look like? So certainly, I mean, I think we're really proud of the growth we've seen in the current physical space. I think there are certainly ways that we'll continue to grow through staffing in that current physical space. But really the next piece that myself, as well as the research support team here broadly, is trying to tackle is, what are the current infrastructure barriers to research support here? Lay-down space is one of them. That's why I'm trying to promote that, so we kind of see what the larger need is. Testing tanks is another one. I think we're really starting to think about what is the next kind of growth need in the engineering side of the campus. So yeah, we're definitely thinking about how we're growing infrastructure around growing the iLab, but kind of research support broadly for marine industry or enterprise, I guess. But we make it work. We're not there yet where we're totally busting at the seams, but that's a good problem to have, I think. Kind of answers. Yeah.
Nice. Questions in the room? All right, 1 second.
Yeah, thanks, Drummond. I was wondering about your current capability for testing instruments under depth or pressure. And I'm
Wow.
kind of thinking specifically about your environmental DNA tester. How deep can it go?
Yeah, I'll give you two answers there. One, so towards the Idola system, it's all designed around 1,000-meter max operating depth. We've tested it, you know, to say 20 or 30 meters, kind of based on some local testing we've done there. So we haven't tested it that deep yet. But then towards what are our testing capabilities in the lab space, there's kind of three different areas that we think about doing in-water testing of some systems. So the first one is going out to the estuary here and using our pump house and the climate monitoring station. There's quite a sophisticated test capability there with a winch setup for lowering experimental instrumentation through a hole in the floor next to a dedicated core instrumentation package that can be comparative. So in terms of water quality, in terms of all of these pieces, hopefully we'll get a seminar coming to you soon on those aspects. So that's kind of one really nice walk across the street testing capability. It's not super deep, but the other piece we're actually writing some grants on this year to finish up the design and build around is our hydrostatic testing vessel. So if you notice in the iLab, there's this big piece of stainless that just sits up against the west wall and doesn't have anything attached to it yet. So we're at the end of a grant to be able to acquire a vessel, but we haven't gotten the pump infrastructure for it. So this vessel is a 17-inch inside diameter, 60 inches tall, and will do 1,000 PSI. So we're thinking kind of shallow and matching what we could do off the shelf here. So shallow and big is the thought process there. The grants that we're going to be writing, I'm working with a group on main campus, the Ben Russell and the CMTD shop, to upgrade their vessel as well. So they have a full ocean depth rated vessel, one of the old ballistic missiles, I guess, that was retrofitted to be able to be a pressure test vessel. And that system can do full ocean depth, but it's small. So what we're going to be working on is building or upgrading both of these systems to the same kind of capabilities, but having kind of a shallow and big and a small and deep capability. And if you have specific needs there, please feed those to me as use cases so we can make sure that kind of as we're doing that design study and as we're kind of speccing out that build, we accommodate any of these things. I think the main thing that we're going to be working on that might be slightly different than other vessels is being able to do dive rate profiles, so being able to program in a ramp rate to be able to calibrate dives, and then being able to do cyclical testing, so being able to run something for an extended period of time and kind of look at fatigue. But so that's two answers perhaps there. Yeah.
Can you build off of that a little bit and talk about the network of iLabs you are kind of collaborating with to main campus and then up and down the coast and how that benefits us?
Sure. Let's see. Yeah. So I think OSU broadly is has enjoyed seeing the model that we've started here and has tried to think about how they bring that into the main campus and start to run that. So the College of Engineering also has an innovation labs and is where they teach their machining out of, and they're also trying to kind of ramp up the prototype design and development they do there, because they're also seeing that that is a wonderful training opportunity for a lot of the students there. So there's certainly a lot of main campus groups that are starting up in that regard. There's other groups that aren't, they aren't called iLab, but there's, say, in the ecological engineering group, we work a lot with the Opens Lab, and they're a wonderful instrumentation design and development space, more on kind of the electronics, but they're actually the ones that developed the software interface for the Adelis system. And so they're a really good partner that we partner with when we have software needs. And in terms of up and down the coast, I think most of the engagement has happened across the OSU sphere. Certainly we're excited with the, bringing and helping out Port Orford more and seeing how we expand some of the innovation space here into Port Orford and help support their work that they do down there. So that's going to be an interesting area of development. That's all that comes to mind immediately. Yeah.
Looks like we still got another question online. Go ahead, Roseanne.
This is a comment. I'm an engineer with the PAC WAVE project, and I had support from iLab to prepare field assets for deployment. Took 3 students out to sea for experience in real oceanographic work and going to lift train wheels to stack for anchors with a gantry crane.
Thanks, Jay. Absolutely.
It's hard to be anonymous when we know who you are. That's great. All right. Any last questions in the room? Drummond, you want to wrap up with anything that you would like to share with us?
If you want to learn any more, I have examples of what we talked through, so we can talk through that. If you need this, you can ask for one. But no, thank you. I appreciate the time.
Thank you, everyone. We all know Drummond's a rock star, but thank you so much for being here and listening to him and learning a little bit more about the iLab. For everybody online, thanks for joining us. And again, just a reminder, we've got one more seminar this year. Hope to see you back next week. Thanks, everyone. Thanks, Drummond.